So when you go to Google Colab, let's check here. So when you come to Google Colab, which is here, you can just go to File, go to New Notebook, click it, and then you have access to a new notebook that you can use to run the Python code. So you don't need any additional library. So we are going to use just the Python inbuilt functions and then commands. So just use Google Colab. So that means if you are going to use Google Colab, you need to have access to the internet. So just get an internet connection and then you'll be fine. Okay, so we are going to start now. So if you're on the Python interface, then we are going to start by creating a string or DNA sequence. Okay, so we are going to create strings, but we are going to try to apply it in the field of biology. So just start the command. So to create a string, let's just say my string. So we assign this to a variable. So you assign this, so we can say bioinformatics. So I have placed everything in double quote. So once they are in double quote, that means that these are string characters. Okay. You can also use single quotes. Maybe as we go along, I'll use single quotes so that you'll be used to both approaches that you can use to create strings. Let me enlarge this a bit. Yeah, this should be fine. So we can continue. Okay, so this is my string. So once I have it, I can just print it. I have created it, so I can print it. I'll say print my string, and then I'll have bioinformatics. You can also just do it straight away. That should work. And then you have bioinformatics. So this one, I use it more like in the interactive session. So I just wanted to display it. But if you are going to use that string in another operation, or if you are going to use it in another command, then you have to assign it to a variable like what I have done here. So this is a string. Let's just also print another one. Let's say hello world. This time I'm using a single quote. So this is how it's going to be done. So I have hello world. Okay, so this is how we create strings. Now we are biologists. Let me just put that because this is Python for bioinformatics. So I'm going to switch to bioinformatics. So let's create a DNA sequence. So DNA sequences are also considered as strings in the field of programming. So let's create one. Let's say my DNA. My DNA equals, let's say A, G, C, T, any of them. So this is in single quotes. So because these are in single quotes, they are strings. So now you have your DNA. So you can print it. You can say print my DNA. So we have printed our sequence. So this is how we manipulate strings. Sorry, this is how we manipulate DNA sequences. Okay, so if you have a DNA sequence, you are analyzing it using some tools. Then behind the scenes, these sequences, they are strings. So you just have to manipulate them as strings and then you can process them. Of course, we are going to manipulate them by looking at all these activities. So just stay tuned and then continue. Okay, so let's continue. Now we have a DNA sequence. We also have our classical strings, and so we can continue and then start some steps. Okay, so let's go. Let's go to the next section. So in the next session, we are going to look at converting strings to lower or uppercase. So that's how we do it in Python. I'll create another string here again so that we can use it. So let's start with one string. Let's say string. Let's see. I'll create it again. Yeah. So if I have the string and I want to convert to lowercase, then I can say my string dot lower. Let's say dot lower. And then I'll just execute the command. So now everything is in lowercase. Let's try another one. Let's say my string 2. This time let's use all uppercase. Let's say hello world. If I want to change it to lowercase, I'll just say my string 2 dot lower. So this has been done for me. So this means that if you're going to change it to a lowercase or uppercase, you need to specify that string object first. Okay, so once you do that, then it becomes easy for you to manipulate them using the inbuilt functions in Python. So this is how we do it. Okay, so we've done that. We've converted or we've changed a string to lowercase. Now let's look at how we can change to uppercase. But before I even do that, let's look at something here. You may have your DNA sequence, let's say like this. Let's say A, G, T, C like this. So if you want to change it to lowercase, then it's dot lower. Then you get it in lowercase. Now let's look at the uppercase. So for uppercase, let's use a DNA sequence first. I'll just do that here. I can say DNA equals, let's say ATGC. So to change to uppercase, then it becomes DNA dot upper. So this is how we do it. Or sometimes you will have it in a lowercase like this, and then maybe for formatting reasons, so you want to present them in uppercase, then you can just use this to do that. Let's try another one. Let's say Bioinformatics. This is a string, so I'll just say dot upper. So I'll have that also given to me. There's another thing we can do. Sometimes you can have your string all in lowercase. And then maybe because it's a name, let's just try this. Let's use something here. Let's use this name. My name equals, let's say Bioinformatics. If there's a name, and then you want to have the first character as capital, so then you can say my name dot capitalize. Let me just confirm from here. I have some stuff here that we can check. Okay, it should be somewhere here. Okay, yeah, so we have done that. So my name dot capitalize. So this is a Z. Take note of that. So now you see that the first letter has been capitalized. So this is how we change the cases when dealing with strings. Okay, so let's continue. Let's move on to the next activity. So we are going to look at how to find the length of strings and sequences. So if you want to find the length of strings, or in other words, the number of characters that make up a string, then we use the len function. Let me show you how. Let's just use this again. My string equals hello world. If I want to get a length, I'll just use the len function. Len. And then I'll indicate my string. So I'll have 11 here. Okay. Now, before I proceed with this, let me say that all these activities here, you can also assign them to variables, but it's something that we are going to look at later on. Now, let's get back to the length of the strings and sequences. So if you have this It's 11. If a beginner, you may be tempted to say that the number of characters here, the length is 10 because we have hello 1, 2, 3, 4, 5, world 1, 2, 3, 4, 5. So you are supposed to get 10. But we have 11. This is because a space is also a character in Python. Okay, so all the alphabets here have been counted plus the space character. Okay, plus the space character. Then that is what gives us the length. Everything in total. That's what it is. So bear in mind that in addition to the alphabet, there are other characters that Python also includes whenever it's counting or finding the length of strings. So take note of that. Okay, so now we can proceed. Now let's switch to a DNA sequence. Let's type this. Let's say DNA again. Let's just use this one here. Or you can also use your own DNA sequence. We have 1, 2, 3, 4, 5, 6, 7. Is it a 1, 2, 3, 4, 5, 6, 7? Okay, this is 7. So if you want to find the length, then it becomes len DNA. So it will give us 7. Okay. So that's how you find. So in other words, we have what? 7 bases. Okay, this sequence is made up of 7 bases or 7 nucleotides. Okay, so now we can continue. So one of the reasons why it's important to learn programming is that in a number of cases, you may not have this short sequence. You will have maybe a sequence which is very long. And so in that case, you can't count. It will be difficult to count. And that is where programming comes in. Let's take a look at this situation here. If you take a sequence like this, I'll just type everything here. I'll copy everything here. Okay, I have a sequence like this, which is very long. So it's going to be very challenging trying to count. But with the len function here, you can count it. So we have 460 nucleotides or bases. Okay, so this is the power of programming. You can assign this operation also to a variable. So you can just say length of sequence equals, and you say len DNA. So then you can use this value later on. You can say, let's say print length of sequence. And then you have 460. So you can use this operation. So for example, if let's say you want to get the GC content, then you have to count the number of GCs divided by the length multiplied by 100 or whatever. And then, so in that situation, you can just assign this operation to a variable and then later on compute the percentage GC. Okay, so that's how we find the length of sequences. Now let's check for the presence or absence of characters or substrings or subsequences, if we call it that way as well. So this time let's try this. Let's get it. Let's see my string. Let's see. I love programming. If let's say I want to check for a character, let's say I want to find if there is a P in this particular string, then I can just say P. That's the query, what I want to find in my string. So if that character is there, then we are going to have true return to us. If let's say that character is not there. Let's try, let's say Z in my string. What do we have? False, because Z is not here. Now let's try this. Let's say P, uppercase P in my string. We have false. You may be tempted to say that P is P. This and this are all P. But why do we have false? It's because in Python is case sensitive. So that means that this P, uppercase P, is different from lowercase p. And so you need to also pay attention to the cases that you use when dealing with strings. Okay, so here is false because there's no uppercase P here. But this is true because there's a small letter, a lowercase p here. So the same applies to all the other alphabets as well. Okay, so let's continue. You can also check for the parents or characters or substring using another command which you call the find. So you can say my string.find. Okay, so this will return a value. So this value here represents the index, the starting index. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is number 8, but indexing is 7. I'll talk about indexing later on, so don't worry. Now for now, just know that when you use the find function, it tells you the starting points in that particular sequence or string. Let's say love, a string dot find. Love is 2. So we have 0, 1, 2. Okay, it starts from 2, the index 2. Okay, yeah. We'll talk about indexing later on, so just stay tuned. Then you get to understand why we have these values there. And you should also know that in Python, counting starts from 0. I'll talk about all these things in the indexing parts. Okay, so let's go. Now we are going to look at counting the number of characters or substrings. This is something that we always do to find the number of occurrences. So we will talk about that also here. I'll start with bioinformatics again. My string equals bioinformatics. Now let's say you want to count the number of O's in this string. Then we have to say a string.counts. And we indicate the character or the substring of interest. So this will give us the count. So we have 1, 2. And by the way, this particular section here, checking for the presence or absence of characters, there are other ways you can use to do advanced queries. Okay, you can use regular expressions if you're looking for specific patterns. It's something that I did not make mention of. So you can do more advanced queries here. But this is something that I'll cover in another tutorial. So for now, just do with what you have now. Okay, now back to the counting of the number of characters of substrings. So we have my string bioinformatics. We are counting the letter O. We have 2 of them here, this and this. So we use the my string, that's the string objects, and then dot counts. So let's try again here. Bioinformatics dot counts O. So we have what? 2, because we have O and O here. Again, Python is case sensitive. So if I do this, a string.counts O, you get 0. because O is different from this. So take note of that. O is different from this. Okay, so let's continue. Now let's use a sequence. We are getting to the interesting part. Let's use a sequence. Let's say DNA equals ATC. Let's use any random one like this here. You can use any sequence that you also have. If let's say I want to count the number of A's, that's adenine, then I just have to say DNA.count A. And I'll get 5 because we have 5 of them. Let's count the number of genes. Running DNA count gene. I have 4 of them. Let's repeat for C. And now let's repeat for T. Okay, so we have them here. So what can we do with this? We can do this and we can use it to find the GC contents. So if let's say you want to find the GC content, the number of genes and seed, because sometimes the GC content is a property that we use to make decisions or make inferences, okay? Or we use to evaluate or decide if a particular sequence has to be treated to this or not, or we even use that to explain certain properties, okay? Or certain properties of sequences or certain behaviors of sequences. Then in that situation, you have to find the GC contents. Okay, there are tools that can be used to find GC content, but behind the scenes, it is these little codes or commands that are being used to do the computation for us. So that's why if you know the basics of this, if you know it's from the beginner's level, if you know the foundation, and it helps you to understand how these tools or programs work. Now let's take a look at the GC content. We are going to apply what we've learned so far to do that. Now I want to find the GC content for genes and then the C's. So what do? You can just do this. Now we have gene, we have C, which is 4 and 1. I can say GC equals DNA.count gene plus DNA.count C. So now we can print GC. So this should give us 5. So this is GC. Now if you want to find a percentage GC, then what do? You first have to find the length. Also, and then you can divide the GC divided by length times 100. So let's try this. Now we know GC. So let's look at the percentage GC. So we need to find the length. So say length equals len DNA. And now to find the percentage GC, we can say what? GC over length multiplied by 100. And this will give us our answer here. Okay. So we have GC, that's the number divided by the length, total length, times 100. Or to be on the safer side, we can just say GC over length. We put them in parentheses and say star 100. And we get our answer here. So this means we can assign the entire operation here to a variable. So you can say percentage GC equals, and then we paste the entire operation there. And then we can get our answer. So we can now print percentage GC. or if you want any other information, if you want extra information, you can just say print %EC. Yes. Bring your comma and say %EC. And then you have it nicely done, because sometimes you will do your computation, but then you need to describe it, because if you put just the number here, then the user may not understand what this is about. So if you add a bit of description like this one, then the user knows that yes, this is %EC. Okay, so if you're running programs and you have text message, or you have a text being displayed in addition to the numbers, then you have these little code that are being used behind the scenes. Okay, so we have %EC, which is good. So how will you find periods and pyrimidines? I'll leave that to you to find out. Now you know how to count them, so I'll leave you to find that. For the counting, you can also count the number of occurrences. For example, let's say you have some pattern that you want to count. You can also do that. Okay, so let's try this. Let's create another sequence. Let's say DNA2 equals gene A gene CT. Now, if I want to count the number of genes, and I can say DNA2.count gene. So we have 42 because we have gene1 and we also have another gene, which is 2. Okay, so this is how we count them. Okay, so bear in mind that when you are counting or you are looking for patterns, there are better ways of doing it. For example, you can use regular expressions to do that. Okay, but this is something that I'm going to cover in another tutorial. Or if you have any challenge like that, you can always contact me and then check with me, and then we can arrange some session together. If you want to book a time with me, I've left some links in the description that you can use to contact and also book a session with me for further tutorials. Okay, let's continue. Now, what about if you want to replace characters or substrings? That is what we are going to do next. Let's say I have my string. Let's say string equals, let's say, programming. And then here I put a gene here. So if I want to replace this gene with a lowercase, for example, I will just have to call my string, the string object, and say dot replace. So I start with what I want to remove, what I want to replace. In this case, gene. We are replacing this with a lowercase. So the gene comes, comma, and then what we want to add. That's a lowercase gene. So let's execute this command. So now I have programming. Okay, this has been done nicely for us. So this is how we replace characters. If let's say you want to replace maybe a pattern, let's take for example, we have, let me just change this. You can also do that. So you can say my string let's replace, bring that pattern of interest. Let's see, let's do this. So it will also be replaced for us. Now let's switch to DNA sequences. Let's say DNA. Let's do it again. If let's say I want to replace the T's with U's, okay, then I can just say DNA, let's replace T, U. Okay, so they have been replaced. Okay, and you know that RNAs are the ones that contain the U's. Okay, so I have this done. So with some additional commands, you can actually change your DNA sequences or convert them to RNA sequences. But this is something that I'm going to cover in another tutorial, where you have to find the reverse and do the swapping and all that. But for now, there's just a simple command to let you know that it's possible to convert the DNA sequences to RNA, okay, by performing some operations and then also swapping the T's with the U's. Okay, so now we have swapped the T's with the U. Take note that whatever we are doing here is just return a copy of the sequences and then modifying that. Okay, so if you want to assign that entire operation to a variable, then you have to add that variable. So let's just assume, let's just say that changing this T here to U gives us an RNA or a transcript. Let's say RNA. Then I can just say RNA equals, and then I indicate my command like this. And then I execute it. So now I can just print RNA and I have it done nicely for me. Okay, so this is how we replace characters or substrings, okay, in Python. So let's proceed. Now we are going to look at how to combine strings or sequences. So if you want to combine strings and sequences, then there are a number of ways you can do it. Okay, I'll give you some approaches here. So let's start with the first one. By the way, combining strings or sequences, we also call that concatenation. So let's just look at some of them. Let's say I have DNA1 plus, let's say AGT. I have DNA2 TTC or TT, yeah. So if I want to combine, I can just say, let's say combined, because I can say DNA1 is supposed to be this way plus DNA2. So now I can print it. So I can say print combine. So that will give me my combined sequences. Okay. Let me just add this. This is approach 1. Okay, let's try with a name. Let's say first name equals Bioinformatics. Second name equals coach. So if I want to combine them, let's say I want to get full name to be equals to what? First name plus second name. So now let's print it. You have it this way. Okay, so there's a name, so you expect that there should be a space character. Okay, so you will be tempted to just do it this way. You can just say this plus a space character plus this. Okay, and then if you print it, you are going to get the full name with a space. But there are much elegant ways of doing this. Okay, so that leads me to string formatting. Okay, so let's look at approach 2. Approach 2 and approach 3 are string formatting. So in approach 2, let's just copy everything here, the first and second names again. So if I want to get a full name, I can say full name equals, and then I bring my quotes, and I'll say %s space percentage S. So there's these are string formatting techniques. And then bring this percentage symbol again, and I say first name, second name. There is something that I'll cover in details in another tutorial. Okay, so if you have any challenge, you want further explanation, you can always contact me. So I can have it this way. So now if I print it, I should have Bioinformatics Coach. Okay, so this and this are placeholders. Okay, the S here indicates that we are going to add a strange character. This is also a string character. Okay, and so these are the string characters. We have 1, 2. The reason why this is a better approach to this, the first one here, approach 1 here, is that here it's easier to combine string characters with numbers. Okay, it's easier to combine string characters with numbers and other data types. It's possible to do that when you have the string formatting. So if you take a look at our percentage GC, for example, let's check this one here. I can do the same thing using this approach here. Okay, I can just, let me just use the print statement, or let me just, I can say this percentage S, or let me just use that because we already had the statement there. So percentage GC is, and I can say percentage D or 0.2F. This is a float character, and then I can just print the percentage GC. So that will also give me an answer. So when you are combining strings, you can use the string formatting to do that. Now, there's another strange formatting approach that is also available. That's the string.format. So that's approach 3. So in approach 3, let's just create this once again. So I have it this way. So I can just say full name equals, bring my quotes, and I'll use a curly bracket and another curly bracket, and I'll say dot format, and I'll say first name, second name. So now I can print it full. Okay, you can do some advanced operations with this particular approach as well, but that is something that is beyond the scope of this tutorial. So let's proceed. Now let's go to indexing and slicing. So indexing and slicing, this technique is used to access substrings or characters or nucleotides by specifying an index or a range of indexes where you have start and end, and in some cases a step or stripe value. So there's a syntax. We have S, that's a string or sequence. We have M, N, that's the starts, and then dash N, and then dash S, that's the step or stripe. So let me also use this to explain something. So in Python, counting starts from 0. Okay, so if I have this, let me do this. If I have this sequence, let's say I have DNA equals ATC. Let me use uppercase. Now, if let's say I should ask you to find the DNA in position, let's say position 2. In indexing, we can just say DNA, and then we give the index value. But because counting starts from 0, the position 2 will have an index of 1. That's how it's going to be. So let's run this. We are going to get J. Okay, so this is how indexing looks like. So we can use indexing to do a number of things. We can use that to find patterns, or even find or extract sequences, extract particular regions, okay, of a sequence. Okay, so let's look at how to do that. I've covered this indexing and slicing in detail in another tutorial, so I'll encourage you to watch that video. I'll leave the link to that video in the description box for you to check, but for now I'm just looking at it at a glance. So let's start. I have indexing and slicing. I also have negative indexing, which is used to access the last element of a string or sequence. We also have shorthand indexing. We will go through all of these. Okay, now let's start with this first one here. Let's say DNA, because let's try any one. Now, if let's say you want to find the DNA, or let's say you want to find the nucleotide in position 3, that will be index 2. Okay, so know that what the counting starts from 0. So the position of interest that you want, you always have to subtract 1 from it, so it becomes -1. Okay, that is if you are making the query from this to this side. So let's say DNA, or let's just say we want the 3rd nucleotide. Let me just use that one. Let's say we want the 3rd nucleotide. Then it becomes DNA 2, because counting starts from 0 in Python. So the 3rd nucleotide will have an index of 2. Okay, that's what we have here. So this one differs from R, because in R counting starts from 1. So if you are doing R and you are new to Python, it might sound a bit confusing, but it's just a matter of you subtracting 1 from that value of interest. If you want the 4th nucleotide, then it becomes DNA, or the string in question 3. That will be the index. Okay, this is what we have. Let's try out another string. Let's say hello. Let's say string 1. Now I'm shifting from DNA sequence. So if I want the letter, the character in, or if I want the 3rd character, then it becomes string 1, 2. That's what we have here. Now let's try this. We have been using just one value, but what about if you want a range? Then if it's a range that you want, then you have to add the start and then end. So let's go back to our DNA here. Let's copy it. I have this. Let's say I want a DNA sequence, okay, of, let's say I want the range, let's say from the 3rd, I want the 3rd nucleotide up to, let's say, the 6th nucleotide. Then what do I have to do? Let's start. So I said DNA 2, because I want the 3rd, from 3rd to, let's say, 6th. So because I want the 6th, from 3rd to 6th, I need to add an extra value. You know, 3rd will have an index of 2. The 6th nucleotide will have an index of 5. So I'll have to use 2:6. When you specify the query like this, Python will return what? The stats up to whatever you have here -1. So in this particular command, we are going to have index 2 up to index 5 being returned. Okay, so this 6 here is more like a boundary, so that Python does not go beyond what it's supposed to do. So let's run this command. So we are now going to have AGTA. Okay, so we have the third, which is 2, 0, 1, 2. So 2, 3, 4, 5. Okay, we have 5 here. So if let's say, yeah, so we had fourth. So there's the actual position. We have position or the third. So I said third to sixth. So that means 3, 4, 5, 6. And that is what we have here. 2 to 6. Okay. So that's what you have. This you just have to know the rules, the -1 rule, and then after that, everything should be fine with you. So that's how we do it. Let's try again. Let's say we want the second nucleotide up to, let's say, the fourth. So then it becomes DNA 1, 2, 4. We want the second as 1, the second to fourth, that will be 3. Okay, so it's supposed to be like this. This is what we actually want. So we add +1 to it like this, and then we can execute. So we are going to have fourth, second, third, fourth. Okay, so that's what we have here. So just make sure to check the documentation for Python, and then you can understand whatever is going on here. Of course, you can also reach out to me if you want the one-on-one tutorial on Python for bioinformatics. So just check the description box. You are going to find my contact there. Okay, so let's proceed. So that's for the indexing and then slicing. Okay, we've done this one where we just specify one value. We've also used a range. Now let's look at the step. This is very interesting, so I want us to look at it. Now let's recreate this DNA sequence, and then let's see. We have a sequence here. Now let's experiment. Let's say we want maybe the first to third. Okay, or let's just say we want, let's say, I think it's better I type this so that we can look at it. So let's do this. Let's say I say this DNA, and I want everything here. I want the interval of 3. That's where the step or stride comes in. So if let's say if I take all this DNA, all these nucleotides here, I want to get some nucleotides here, but I want the third. I want an interval of 3. So that means that I want the third of this, the third, the third, the third. So then we can just say, let's say 0, 9, and then 3. I want something like this. So let's run this. So I have AGG. The 9 here itself will not be included. So in reality, what we are looking at is 0 to 8. So the step here is 3. So that means every third member. So we will start with the first one here, which is 0. That is A. Okay. Now we count 1, 2, 3. That is G. That is what is here. And now we count 1, 2, 3. That is another G. Okay, so that is the step I was referring to. Okay, that's what we have here. So you can always swap, or you can change the values to see what comes up. So this principle can be used to generate codons. This is something that I've also covered in another tutorial, but you can check it. I'll leave the link to that video in the description box for you to check. So it is this principle where we have start, end, and step that can be used to get the codons for you. So make sure to check that video. I think it's going to be very helpful for you if you want to learn further. So this is how we use the step as well. Okay, so now we have our indexing and slicing. We have one index, we have start and end. We can also add a step. Okay, so just take note of that. Now let's take a look at that thing here. Let's look at negative indexing. Let's remove these ones first. So negative indexing is used to access the last element of a string. So let's look at how that can be. Let's recreate this sequence here. I'll just paste it, and then let's look at what I mean by negative. So negative index means that the value that you are using, I mean, we specify 2, 6, 4, etc. We make it negative. So with negative indexing, let's say DNA -1. So with negative indexing, counting starts from 1. We don't use 0, we use 1. So if I want the last element, then it becomes -1. So that means I'm starting the counting from this side. Okay, so just like how we have 5' and 3' for DNA sequencing, then sometimes you go from 5 to 3', sometimes 3 to 5'. Okay, so we have something like, so if I want the last nucleotide or the last character, then I can use this to get it. So let's see how we get it. So it's A. What is the last? Of course, here if we have A and A, let's just use this to get started. Let's change this one to T. Now let's do it again, DNA 1. Okay, so we have T. If you want this one, okay, the nucleotide just after the last one, then of course you have to use 2. So we can say -2. So that will give us gene. Okay, now let's try something. You can also use this technique to also get the reverse sequence as well, but that's something that we are going to look at in the next session. So you can also do this. You can do this. Let's see, 5. So here we are going to start from position 5 up to the end, the last. That's what this one means. So let's run this. So we are going to start from here up to the last, which is here. So 0, 1, 2, 3, 4, 5 position. Let's do it. 0, 1, 2, 3, 4, 5. That's A. Okay, this up to the end. That's what this other one means. Now let's look at this one here. This one, what DNA? This will return a copy. So to return basically a copy of the sequence of interest. Okay, the sequence that we want to make the query on. So it's just a copy. Now let's look at this one here. This returns the reverse of the entire string. Okay, so that one is let's say, yeah, DNA, and I have this /1, and this will return a copy as reverse. So that's what you have here. Now let's type DNA. This is what we had, and now let's look at DNA. This one, that's a reverse. Okay, so I have that also here. Okay, so that's what I have. Okay, so this will return the reverse for us. That's the reverse sequence. So reverse sequences, I've also covered them in detail in another tutorial. So just to the description box, you'll find the link to that video there. Okay, and for these things I've done, I've made for some of the sections, some of the parts, I've made detailed videos on that. And so if you want detailed explanation, then just check the appropriate video and then use them. Okay, so this for the other one. Now let's check. So with strings, you can also manipulate them using other functions which I've not covered. I've not covered all of them, but you can look at what we have here, just experiment and then use the ones that are appropriate for you. Okay, so this one like this, I'm going to cover that in another tutorial. Okay, because we are going to cover the list objects in another tutorial. So this one's to just read them, get the explanation, and then you'll be fine. So just practice and then everything should be fine. for you. So that's it. So for beginners, I will encourage you to just practice the Python programming, and then it's more about being consistent. And I believe me starting from scratch is going to help you beginners. So as a matter of fact, there's nothing to be scared of when it comes to programming. You just need to practice. Okay, and I think you being biologist and me using the DNA sequences makes it less scary and more enjoyable. So just make sure you check the description box for useful videos. Okay, thanks. I also have some information. It says this is a good lecture. Please share your experience of the use of Python for analysis of large data sets. Okay, yeah. So for large data sets, I mean, I've covered some of them, but it depends on what you want to achieve at the end of the day. But I think if you have some topics, you can just bring them up, and also because I always have lots of requests, you can also sponsor a video, and then I'll try and then make that for you. So yeah, that's also fine. So again, you can support this channel. You can also sponsor videos. Anyhow you want to support the channel, it's accepted. So just make sure you support. Links that you can use to support in the description box. Okay, so let's proceed. So just check these additional functions here, and then you can use that to manipulate your strings and then sequence. So whenever you are analyzing sequences, when you are using these tools to analyze some of these sequences, behind the scenes, what is happening is these little codes, this not little per se, but these simple codes that are here. So just a combination of these simple codes that give us those results, or those statistics that we get when we are analyzing sequence data. So make sure you check this video, reproduce, and then just develop an expertise in the field of Python programming and bioinformatics. Okay, so now let's proceed. Now let's look at this exercise here. Okay, this is the last thing we are going to do, but I think you can also try and then just answer them if you can, but you will try to answer that here. I will just do this. We are going to answer them all here. So I have this sequence. It says consider a DNA sequence this. How many nucleotides are present? Okay, so let's start with question number 1. We have how many nucleotides are present, calculate GC, percentage GC, how many purines, pyrimidines, calculate percentage of purines, etc. So we are going to take a look at these questions one by one. I think it's going to be very helpful. So question 1, how many nucleotides are present? Before we even do that, we need to what? First create this sequence. It's a string. So that means we have to create the sequence. Okay, so let's say DNA. Let's use this. So I have that created. So now I can answer. So question 1, let me check. Question 1 is how many nucleotides are present. So in other words, we are looking at the length of the sequence. So if you want the length, then it's what? Learn what? DNA. Simple. Then we get our answer. So we have what? 23 nucleotides. That's what we have here, basically. Now let's look at question 2. Calculate the percentage GC. So how do you do it? First, you need to get a GC content. So that means it was GC is equals to what? DNA.counts G plus what? DNA.counts C. And then you also need to get the length, which is what? Len DNA, which I've already covered. And then percentage GC. GC is equals to what? GC over length times 100. So now you can print your GC, percentage GC. You have it here. Okay. Now we can convert, or we can change the we can change the decimal places. If let's say you want 2 decimal places, then you can just say percentage GC equals round percentage GC, and then to, let's say you want 2 decimal places. So now I can print it, and then I'll have my answer. So I have 52.17. Okay, let's look at question number 3. How many parents are present? Parents are A's and then G's. So get the parents is equals to what? DNA.count A plus what? DNA.count G. Yeah, let me make it a bit description. I'll say number of parents. So now I can print this number of parents. It's 15. Question number 4. How many pyramids? So it's the same principle here. Okay, by this time we change. Let me just do it again. So I'll say number of pyramids. So that'll be what? DNA.count. And that'll be what? C plus DNA.count T. We have C and T. So now I can print its number of pyramids. So I have 8. So this was for question number 4. Now let's look at question number 5. Question number 5 is calculate the percentage of purines in the sequence. So if you want purines, I already have that here. I will just copy this code here. So if it's percentage of purines, I need to get my number of purines. I need to get my length, which I've already done here. I'll just do a copy and paste here. And then when I come to percentage of purines, then it becomes what? Number of purines over length star 100. That's times. For these mathematical operations, I'm going to cover them in another tutorial. So for now, I'm just giving them bits. I'm giving them to you in bits. Okay, so I have this. So now I can print percentage of purines. Okay, so I have that here. Again, you can change it to 2 decimal places. So this one, I'll leave it to you. So that's your assignment. Number 6, question number 6. Which nucleotide is in the 10th position? So nucleotide in the 10th position is going to be what? Let's just say, let's just use this. Nucleotide number 10 is going to be what? DNA 9, because counting starts from 0. So I can print it. So that's G. So you can count. You can just count them manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's G. But of course, indexing, we start from 0. So it's what? 9. Let's look at question number 7. Write the sequences that are present in position 3, 2. position 9. So here we are looking at a range. Okay, so nucleotides, what's position 3 to 9 will be equals to what? DNA 2. Because we're looking at positions 3 to 9, or the third nucleotide to the 9th nucleotide. Let me just put it that way. So 2 to 9. So why are we saying 9? Because we want the third nucleotide to the 9th nucleotide. Okay, so the 9th nucleotide will have an index of 8, but we have to add +1 so that we get that value itself. That's why we are adding this. Anyway, you can always experiment. Some of these things, it may sound confusing, but then when you practice, when you repeat them, you do it, you make mistakes, you repeat, then you start to get a hang of things. So just make sure to practice, and then when you do it for some time, you understand why some of these things are there. And some of them are rules. I can't change them. So these are the rules that were set by the creators or the creator of Python. So you just have to follow. It's just like learn a language. There are rules. So you just have to follow the rule and then you'll be fine. So let's run this. I'll print nucleotides 3, 9. So I should have the answer here. Now let's look at question number 8. What command will you use to find which nucleotides are present from position 10 to 20? What command will you use to find? So it's basically the same thing here. Okay, the same thing I've done here. So this time I will just copy and then I'll modify the code here to give me 10 to 20. So let's see. So 10 to 20, that'll be what? 9. Okay, let me use the actual value here. But when you come here, it becomes 9 for this. So now I can print it. I'll just print that here. Okay, so that's what we have here. So this is what's 9 to 20. So this 20 here will not be included, but we have up to 19, and 19 is the hot 20th position. Okay, so let's go. Now we are going to question number 9. Does the DNA sequence contain GGAGG? Question number 9. So we have to look for this. So how do you do this? Let's see. So we have to just query. I can just do this in DNA, and it's true. Okay, it's there. But if it's there, then how do we locate it? So then I can use what? Let me just add that here. I can just say, let me use a print statement here first. I can say DNA.find to locate where it starts. Yeah, let me use a print statement so that everything will be displayed. So 9, it starts from index 9. So let's check. Index 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's gene. That's what we have here. Okay. So if you want the exact range, then you have to use regular expressions to do this. But this is something that I'll cover in order to write. It will be a detailed video. So for now, I'll skip it. Question number 10. What do we have? How many times does TT occur? So you can say DNA.count. TTA 2 times. Okay. Please take note that this particular approach sometimes to may not be appropriate. Okay. There are situations where you have, let's say you have TTA, you can also have other nucleotides, making it a bit complex. And so there are better ways to count. Okay, you can use regular expressions, or if this were to be a list data type, then of course this one will work for all situations. But for the string data type, this approach sometimes may not work. Okay, so just take note of that. But of course, that's why you are learning, so you can just build on whatever you've been taught today. Let's look at question number 11. At which index does GTA begin? That's question number 11. So, of course, here we can use the find to do that. So I can just say DNA.find. And then I'll just paste it. So I have 1. Okay, index 1. Let's see. Let's check. 0, 1. We are looking for JTTA. Let's check. Yeah, so we have index 1. But here, what we should note is that if GTT occurs more than 1, okay, if you have, let's say, 2 or more of the GTTs, then this approach may not work. That's why I recommend that you use regular expressions. Okay, in some situations, the find and the count command may not work appropriately. So you just have to look at the situation and look at the appropriate method that can be used. But regular expressions, that one, I mean, you are sure of getting the right result when it comes to the find command. Now let's look at the last question. That's question number 12. Does the sequence contain the character Z? Of course, this is simple. So you see what? Z in what DNA is false. Okay. So here, we have DNA sequences, we have protein sequences. So for DNA sequences, we should have A, C, G, T. If you are dealing with RNA, then you also are expecting to find U. Okay. But if you see any other character like we have Z, then that means that it's invalid. It's an invalid sequence. Okay. So I mean, you can also use this to check if there are characters in your sequence which are not supposed to be there. So that's how we do it. Okay, so this is it for this tutorial. And then just make sure to check the description box. You'll find the link that you can use to download this notebook, as well as other bioinformatics tutorials that I make. So just to the description box and then get all that information. So if you also have any other comments, if there are things that you think should have been added, then you can just put them in the comment section, and then you can all discuss and then learn something new. So that'll be all for this tutorial. Tomorrow, which is Wednesday, we will look at Linux. Okay, Linux for bioinformatics. So I'm starting from scratch. So tomorrow we will look at Linux for bioinformatics at the beginners level, and that will be, I think I'll also make it 5 p.m. GMT, because I think that one works for most of people. So 5 p.m. GMT, we have the Linux for bioinformatics. And then on Thursday, 5 p.m. GMT, we are going to have R for bioinformatics. So